Hello friends, today's question. A hemispherical portion of radius r is removed from the bottom of a cylinder of radius r. The volume of the remaining cylinder V is V and the mass is m. It is suspended by a string in the liquid of density ρ where it stays vertical. The upper surface of the cylinder is at a depth h below the liquid surface. The force on the bottom of the cylinder by the liquid is. So this is a figure. So we have this cylinder and you can say hemispherical portion of radius r is removed from the bottom, and the cylinder is always vertical and the topmost portion of the cylinder is at a height h. So in this case basically we are going to use the buoyant force as well as the pressure at the depth h or whatever depth it is, and we are going to equate them because the cylinder is in upright position, that is it is in equilibrium, and try to solve it. So first of all let us find out about the buoyant force. So we know that buoyant force is a upward force exerted by the liquid on the submerged cylinder submerged portion of the cylinder due to displacement of the liquid. And is equal to weight displaced by the liquid, weight displaced by the liquid. So this is the basic about the buoyant force, and it is given in the question that the remaining volume is V and mass is m. So therefore the buoyant force will be only responsible or only depending upon the volume V and the mass m. Okay, it will not be depending upon the mass or the volume which have been removed from the cylinder. So you can say then buoyant force acting on remaining cylinder with volume V, because volume V is also already given that after the hemispherical portion has been removed, the volume of the cylinder is V, remaining cylinder is V. Okay, so therefore the buoyant force, let us suppose it is represented as FB. So FB will be equal to rho multiplied by V multiplied by G, where rho is the density of the liquid, and G is the acceleration due to gravity. And this buoyant force acting in upward direction. acting in upward direction. So buoyant force will be acting in upward direction. Now there will be some force on the topmost edge of the cylinder because of the liquid that is at a height h above the cylinder. So let us find out that force due to pressure at the top. Force due to pressure at the top, let us call that as F top. So we can say that force due to pressure at the top of the cylinder, top of the cylinder is the result of the liquid, pressing down on the top surface of the cylinder, pressing down on the top surface of cylinder, and this pressure we can say will be due to the height which is given as h. This pressure is due to the height of the liquid, h above the cylinder, above the top of the cylinder, rather top of the cylinder. So that can be said as pressure at a depth h pressure at the depth h will be equal to P, and this will be equal to rho g h, where rho is once again the, you can say, density of the liquid, and g is the acceleration due to gravity, and h is the height, or rather we can say h is the depth in this case. So we can write that force acting on the top, therefore force acting on the top of the cylinder, which we said is F top, is equal to pressure multiplied by area of cylinder, which is equal to pi r square. Radius is given to us. Radius is not given to us. That is given, capital R. Cylinder of radius capital R. So therefore we can say F top is equal to rho gh, and area of cylinder is equal to pi r square, where r is radius of cylinder. Now we can find out, because in the question we are supposed to find out the force on the bottom of the cylinder by the liquid. So we have to find out the force at this point. So we found out the force at the top, and we found out the buoyant force which will be acting in the bottom, and from here we can say the difference in the force in the, you can say, top and bottom will be equal to buoyant force. So force at the bottom of the cylinder, force on the bottom of the cylinder, let us call that is F bottom, so we can say from here that the force on the bottom of the cylinder will include the liquid pressing down from the above, include the liquid pressing down from the above, and buoyant force pushing up, and buoyant force pushing up. Therefore, as it said that the cylinder is in vertical equilibrium, so it means the forces will be in balanced. Okay, it will be balanced. So therefore we can write the force balanced equation which says that F bottom minus F top is equal to buoyant force. So we get from here that F bottom will be equal to buoyant force plus F top, and buoyant force is our rho Vg plus F top is our rho Gh multiplied by pi r square. So taking rho G as common, so we get rho G, and from here if we get pi r square plus volume V, so this is our F bottom. So you can see this is the force acting on the bottom of the cylinder. This is the force. This is the force acting on the bottom of cylinder, and from option that is available to us, you can see that option number D is the correct option. Option D is correct. So this completes the question. Thank you.